Here's example 5 of evaluating trig expressions using sum and difference formulas. So we're going to use this formula sheet we've been using. So here we have the tangent of 5 pi over 12. We want to evaluate that. If you want to copy this formula sheet, check the video description. There's a link in there. You can use that link to get a copy. Okay. So 5 pi over 12 is not a special angle on the unit circle, so what we want to do is express it as a sum or difference of two special angles on the unit circle. So first what we can do is say, okay, 5 pi over 12, so we can express it as, let's try, so 5 we know is 2 plus 3, and 2 and 3 both reduce with 12, so let's see if that gives us anything useful. So 2 pi over 12 plus 3 pi over 12. Okay, well 2 goes into 12 6 times, and 3 goes into 12 4 times, so this is pi over 6, and then plus pi over 4. Okay, so that's pretty helpful. Okay, so pi over 6 and pi over 4, they're both special angles on the unit circle, so that's great. Now we can express 5 pi over 12 as the sum of two special angles on the unit circle, so we're good to go. Okay, so tangent of 5 pi over 12 equals the tangent of pi over 6 plus pi over 4. Okay, so now we're just pretty much going to use the formula then, so let's maybe come down here. Okay, so we have tangent of, here's our alpha, and here's our beta. So it's tangent of alpha plus beta, so we're going to be using this formula up here. Tangent of alpha plus beta is the tangent of alpha plus the tangent of beta, all divided by 1 minus tan alpha tan beta. Okay. So this is going to equal the tangent of pi over 6 plus the tangent of pi over 4, all divided by 1 minus the tangent of pi over 6 times the tangent of pi over 4. Okay. Okay, so now it's really just a matter of knowing the unit circle. So tangent of pi over 6 is root 3 over 3. Kind of running out of room down here, so this is root 3 over 3. And then plus tangent of pi over 4 is 1. Okay, so then on the bottom we have 1 minus tan of pi over 6 is root 3 over 3. So 1 minus gives us 1 minus here, and then tan of pi over 6 is root 3 over 3. Tangent of pi over 4 is 1. Okay, so kind of a squished in mess, so let's come up here and rewrite it. Okay. So on the top we have root 3 over 3 plus 1. I'm going to flip those just to keep it kind of consistent with what's on the bottom. Because on the bottom we have 1 minus root 3 over 3. So on the top let's have 1 plus root 3 over 3. So it'll look a little nicer. Not that it has to, but... So 1 plus root 3 over 3 on the top, and then on the bottom we have 1 minus root 3 over 3. Okay. So complex fractions like that, they're really not nice, so we do want to get rid of them. So what we could do is multiply the entire top by 3. Let's actually use a different color for that. We can multiply the entire top by 3, so that's going to kill this denominator up here. But since we do that to the top, we also have to do it to the bottom to make that okay. Well, that works out great because that's actually going to get rid of this 3 down here too. Now, if you don't like this, I like it because it's a nice shortcut, so what you have to do is just look at your denominator, see what you have to multiply by to get rid of them. Whatever you do on the top, make sure you do the same thing on the bottom. Okay, that's really all you have to do. And if you don't like that, you could just get a common denominator, so you could write this as 1 is 3 over 3, 1 is 3 over 3, so you can write that as so. But anyway, whichever way you choose to do it, you're going to end up with, if we distribute the 3, 1 times 3 is 3, and then plus root 3 over 3 times 3 is just root 3. And then distribute the 3 on the bottom, 1 times 3 is 3, and then minus root 3 over 3 times 3 is just root 3. Okay, so this is root 3 divided by 3, and then times that 3 if we distribute, we're just going to end up with this here. So this here looks like a fairly nice answer, right? But you might have to rationalize the denominator. And if you've seen some of my earlier videos, you know how I feel about rationalizing the denominator in general. I think it's ridiculous how we just apply it to everything. It's not always the right thing to do. It's not always, it doesn't always simplify. The goal really is to simplify as much as you can, unless specified otherwise. But rationalizing the denominator does not always simplify. But actually, in this case, if you rationalize the denominator, you really will get something quite a bit simpler. So let's see what happens if we do that. Okay. So up here we multiply by 3 over 3 to get rid of the complex fraction. And if you don't like doing this, you could just do a common denominator type thing, and you'll end up with the same result here. So now let's rationalize the denominator. So if you have something like 3 minus root 3 in the denominator, then what you do is multiply the top and the bottom by what's called the conjugate sometimes. That's going to be 3 plus root 3. Okay. So multiply the top and the bottom by 3 plus root 3. Okay, and then what we're going to have is, so 3 plus root 3 times 3 plus root 3 on the top. So actually what we want to do there is FOIL. So 3 plus root 3 times 3 plus root 3. So if we FOIL, first gives us 3 times 3, which is 9. Outer gives us 3 root 3. Inner also gives us 3 root 3, right? So it's 3 root 3 plus 3 root 3. Okay, so we'll just write that out. So 3 root 3 plus 3 root 3. And then last, root 3 times root 3. If you have the square root of something times itself, then, so square root of something times square root of that same thing is just going to be that thing, because it's square roots multiplied by itself. The square root goes away. It's basically just the square root squared. And when you square with square roots, the square root goes away and you just have that thing left, m, okay, which in this case is 3. So then plus 3. Okay, so first, outer, inner, last. First, outer, inner, last. Okay, and then if we do the same thing on the bottom, what happens? First is 3 times 3, 9. Outer plus 3 root 3. Inner minus 3 root 3. Okay, that's the whole point of multiplying by this conjugate. So if you change the sign, SIGN sign in here, minus and plus, then what actually happens is this cancellation thing here. So the radical cancels, and that's nice. And then minus root 3 times positive root 3 becomes minus 3. Okay, because just like up here, root 3 times root 3 is just plain old 3. And then root 3 times root 3 is plain old 3, but now we have a minus sign in front. Okay? So let's go ahead and simplify this. So there's enough room here, just barely. So 9 plus 3 is 12. And then 3 root 3 plus 3 root 3 is 6 root 3. Okay, because it's the same thing inside of the square root, we can combine them. So it's really just like 3x plus 3x. Okay, so if you say 3x plus 3x, that's the same thing as 6x, right? So instead of x, we have square root of 3, so that's just kind of an algebra thing there. Okay, so remember that from your algebra days. Okay, so anyway, it's root 3 instead of x, but it's the exact same concept, just 3 times this thing plus 3 times the same thing. It's going to be 3 plus 3 is 6, so it's just 6 times that thing, 6 root 3. Okay, that takes care of the whole top. What about the bottom? Plus 3 root 3 minus 3 root 3, gone. Those are gone, that's great. 9 minus 3 is 6. Okay, so notice there's common factors here that we can cancel. So 12 plus 6 root 3 all divided by 6. We can simplify that quite a bit. So we're kind of out of room down here, so let's come up here. Okay, so what we have is 12 plus 6 root 3 all divided by 6. So let's factor out this 6 from the top. So if we factor out a 6 from the top, what's left is, well, 12 is 2 times 6, so it's going to be a 2 left. And then if we pull a 6 out of here, then we still have the root 3 there. Okay. And then we're dividing by that 6 on the bottom. So the 6 cancels with this 6, which is great, because now all that's left is 2 plus the square root of 3. Okay, so that's 2 plus the square root of 3. And that is our final answer. Okay, 2 plus the square root of 3. So let's give that some space. Okay. So remember what we did is we just applied this tangent formula with tangent of alpha plus beta. And then we just first we split out 5 pi over 12 as 2 pi over 12 plus 3 pi over 12. 2 pi over 12 is pi over 6. 3 pi over 12 is pi over 4. So 5 pi over 12 is pi over 6 plus pi over 4. So then we use the sum formula for tangent. And that's what this is here. Then we just use the unit circle. Tangent of pi over 6 is root 3 over 3. Tangent of pi over 4 is 1. And we ended up with this mess here. Multiply the top and the bottom by 3 to get rid of the complex fraction, or just do common denominators. 1 is 3 over 3, 1 is 3 over 3. That'll give you common denominators. Simplify. We end up with this here, and then if we rationalize the denominator, which I'm against applying in general because it won't always give you something simplified, but in this case it really simplifies pretty nicely. Okay, so if you have something like this, on the bottom and something like that on the top, then usually that's going to give you something nice if you rationalize the denominator. So we had 3 plus root 3 over 3 minus root 3. If we rationalize the denominator, go through all that, we end up with 2 plus the square root of 3, which really is quite a bit more simplified than this. So that's our answer here, 2 plus the square root of 3. And that's example 5 with using the sum and difference formulas for evaluating a trig expression. And again, here's our answer.